In our past 3 units, we've been looking at how to classify functions as even, odd, or neither even or odd. We looked at it in a tabular standpoint. Graphically, we also looked at it talking about the symmetries. A function is even when it's symmetric about the y-axis. And remember, when you do something reflecting it over the y-axis, that's the opposite of the input. So when the original is the same as the opposite of the inputs, we know it's an even function. Symmetry about the y-axis. A function is odd when it has symmetry through the origin. So if you think about when you're talking about symmetry through the origin, we're taking the opposite of the inputs and opposite of the entire outputs, the function. And so when that symmetry through the origin exists, we can say that it's odd. So we're going to look at these rules and those transformations with our function here for number 7, which is g of x equals x to the fourth minus 2. So we're going to get it set up and ready for the two transformations, the opposite of the inputs versus the opposite of the function. And we're going to substitute those in to the original and see what results. So again, when we have something to the fourth power, that means we have 4 of them being multiplied together. So a negative times a negative is a positive, times a negative would be a negative, times a negative would be a positive. So we're going to have x to the fourth minus 2 here. Taking the opposite of your outputs, your whole function, would be like multiplying a negative 1 through your function. So we've got a negative x to the fourth plus 2. So thinking back to your rules, you want to see if it's symmetric about the y-axis or symmetric through the origin. If it's symmetric through the origin, the two transformations should be exact matches. Okay, and we can see that they're not. So it's not an odd function. Then, if it's an even function, the original should match the opposite of the inputs, okay, reflecting it over the y-axis. And I can see that this is an exact match here. G of x is the same as the g of the opposite of the inputs of x. So I would classify this as an even function.